Hi, this will be quick and small recap of basic terminologies of OpenRAN ecosystem and quick recap of ORAN deployment architecture. We will start from the quick architecture overview. You can see that there are different nodes and functions located at different places and interconnected with some interface. We have the general purpose hardware setups which are shared between the different functions through the virtual machines and virtual functions. We have Virtualized Infrastructure Managers (VIM) to manage the VNFs, Virtualized Network Functions. The architecture in the screen of ORAN and 5G technology gets deployed on top of it, and we have different deployment options as well, which can be used to cater different type of services. And based on the needs, we can place these network functions at different locations. Like some functions can be deployed at edge level and some can be deployed at regional level, and even some can be deployed at customer locations too. Same way, you can see the 5G core network functions. In some cases, they are placed near to users, like at edge cloud if the services or applications needs low latency, and for some other use cases, these can be deployed at regional cloud. Some other control plane functions are generally kept at core cloud or in data centers, like virtual AMF, access and mobility management function, virtual UDM, unified data management function, virtual AUSF, authentication server function, virtual PCF, policy control function, and SMF, session management function. You can see that virtual UPF can also deploy it at core cloud in some cases. Now you can feel that deployment of functions are how convenient in OpenRAN systems, and they also provide the great level of flexibilities. Next, you can see the operational applications which can be deployed in the network at different stages. These can be third-party applications or APIs who can offer very specific use case to the telcos. And these can be based on AI, artificial intelligence, and machine learning for new and more advanced features. To control all these functions and enabling them, disabling them, terminating them, starting them, etc., we have orchestrator on top of that, who coordinates with all the managers and sends the instruction to fulfill the network requirements based on the needs and for continuously optimizing the network resources. Let's quickly recall what function do what action in very brief. AMF in 5G, access and mobility management function. This is control plane function in 5G network. AMF is responsible for registration and deregistration of users with 5G network. It handles the establishment and release of signaling. AMF is also responsible for tracking the mobility of the UE locations. UDM, Unified Data Management. This is again part of core network and handle control plane functions. This is same like HSS in 4G, but the HSS responsibility is split in 5G between UDM and AUSF. So UDM manages the user data like data of subscribers and their subscriptions. AUSF, authentication server function, has the responsibility to authenticate the user if he is applicable to access the network and availing any service. It also communicates with the UDM to get the subscriber data. It is also the control plane function and part of core network. SMF, session management function, again function of control plane and part of core network. SMF is responsible for the PDU session management. ODU, open distribution unit. OD unit is responsible for higher physical layer, MAC layer function and RLC layer functions in the RAN protocol stack. These layers works on NFV, Network Function Virtualization, or containers in case of cloud system. The COD server, commercial of the self, first installed with the NFVI software, which enable the virtual resources like compute, storage, and network. ODU software or application then gets installed on this virtual server, and your ODU is ready for function. There is orchestration software on top of it, which manages all the underlying softwares and hardwares for upgrades, scale up or scale down, or the hailing purposes. Next is OCU, Open Centralized Unit. OCU handles the higher physical layer functions of BBU OCU handles the PDCP layer function and SDAP layer functions. It also handles the RRC function for the control plane. Radio Intelligent Controllers. RIC is responsible for all the RAN operations and optimization procedures like RRC management, mobility management, QoS management, edge services, etc. Third-party application which can be based on AI, artificial intelligence and machine learning can be set up on RIC for best network optimization and can provide the good user experience and provide the effective network operations. In the Open RAN architecture, RIC is further classified into near real-time RIC and non-real-time RIC. Near real-time RIC controllers connects to the CU and DU units through the A2 interface, and it connects with the non-real-time RIC through the A1 interface. Near real-time RIC can control the mobility management, QoS management, interference management, radio connection management, etc. This was the high-level overview of Open RAN ecosystem. I hope now you are aware of the terminologies which are generally used in Open RAN system. We will gradually increase the insights for different Open RAN functions in the later series, so stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video and don't forget to share. Thank you for watching.